All right, guys. So for today's lesson, we're going to be talking about verifying trig identities. Okay. Now, how is verifying trig identities different than simplifying? Well, essentially, it's very, very similar. I actually think these ones are a little bit easier, and I'll kind of tell you in a second. But essentially, what verifying is it means that both sides of the equation are equal, right? So we're going with one side, right? You're not going to work from back and forth from one to the other. Typically, you're going to work with the more complex side, and you're going to simplify it to look like the other side. All right. So now, the reason why these are so much easier than simplifying what we did in the previous one is because you have an end goal in mind. All right. So, for instance, number one, I've got cosecant of theta times cosine squared of theta plus sine of theta equals cosine of theta. All right. So, this is what we're trying to get it to look like. All right. So, we need to get this side. It's obviously more complex. We need to get this to look like this. All right. So, a couple things to keep in mind. All right. This is cosecant. We've got a cosecant. We've got a cosine squared. We've got a sine. I wrote squared, but it's not supposed to be squared. All right. So this is number one in the notes. So obviously we're going to have to add this together. All right. So what I'm going to do is I'm going to go ahead and see what we can do to add this together. All right. So we obviously want to combine these together at some point. Right. So what I'm going to do is I'm going to take this cosecant, and yes, I realize this is our end goal, but the other two terms are regular functions, sine, cosine, tangent. All right. So I'm going to go ahead and flip this over. 1 over sine of theta times cosine squared of theta plus sine of theta. All right. I'm going to go and multiply that and bring that together. I want to go ahead and make that denominator sine of theta. Okay. The first fraction already has that denominator of sine, so we don't need to change anything there. But the second one, this has a denominator of 1. So we had to multiply it by sine, so we multiply this by sine, and sine squared. Okay. Right off the bat, right, that cosine squared plus sine squared, okay, should let you know that that's a Pythagorean triple, or a Pythagorean identity. So that's going to equal 1. And 1 over sine of theta is equal to cosecant of theta, which is what we were looking for. Okay, so what did we do here? All right, first we used the reciprocal. Okay, we just multiplied there. We didn't use one of the identities. Ooh. Okay, here we found a common denominator, added together. Okay, so we combined using the common denominator. The next one we used the Pythagorean identity. All right, cosine squared plus sine squared is equal to 1. And then we had our reciprocal. Okay. All right, and then we can say it equals cosecant of theta. All right, so let's take a look at another one. Now, so this next one, I'm actually going to show you two different ways that we can do this. So some of you might look at it and say, well, I don't really know which one's more complex. You may see one way or the other. All right, so I'm going to show you two different ways on this one. First one, we're going to just call this method A. All right, so what I'm going to do with method A is I'm going to simplify the left side. Now, keep in mind, all right, we want to try to get this to look like this. All right, so if I want this to be one term to be two terms, at some point I'm going to have to split the fraction, okay? But I split the fraction here if we only have one term in the numerator, okay? So in order to get two terms in the numerator, I'm going to look at identities and say, all right, well, sine squared of y, I know if I use one of the Pythagorean identities, right, the sine squared plus cosine squared equals 1, that I can replace that with cosine squared, 1 minus cosine squared of y. Okay, so now that I have two terms, I could split that up into two fractions. 1 over cosine of y minus cosine of y over cosine of y. Okay. And it's starting to take place a little bit. We can use our reciprocal function. 1 over cosine is secant of y. And cosine squared of y, cosine of y is cosine of y. All right, which is what we were looking for. Okay. So what did we use? All right, first we used the Pythagorean. Right. Then we split our fraction. And then we used our reciprocal and we simplified. Right. I'm going to simplify the right side, right? Because you may think that looks a little more complex. Okay. So if I simplify the right side, okay, once again, I've got sine y and cosine, and I've got secant and cosine, right? So what I ultimately want here, because I have both of my regular functions and I have a reciprocal, is I'm going to go ahead and change these back into the regular. So simplifying the right side, I'm going to change it to 1 over cosine. Cosine of y. Okay. I have two terms and we need to try to get it down 1. Okay. And I'm going to make a common denominator, but notice we're already what the denominator is. All right. So that should give you a little hint moving in. All right. So I'm going to make my denominator of cosine y. Okay. We don't have to do anything to the first fraction. The second one, I got to multiply by cosine. It already is cosine. So it'll be cosine squared y. We go ahead and subtract. So 1 minus cosine squared y in the numerator. Cosine y in the denominator. In my Pythagorean identity, same thing that we did up here. Got sine squared y over cosine y, which is what we're looking for. Okay. If you see something where it's like equally complex, you can use either side. There's not one surefire way or another. Sometimes it's more obvious than the others, but sometimes it's not. Look at a couple more examples here. All right. So on this one, I got cosine squared of theta, or alpha, on the left, and sine squared of alpha times cosecant squared of alpha minus sine squared of alpha on the right. Okay, this one's a little more obvious as to what we want to use. I want to use the right side. So first thing, I got cosine alpha. That's our end goal. That's what we're trying to get it to look like. We could do a couple things here. There's actually, I did this differently the first way. I'm going to show you one way because this way actually just popped out at me. But we're multiplying a function by its reciprocal. So sine squared times cosecant squared. Anytime you multiply something by its reciprocal, it's equal to 1. So that all right there just becomes 1 minus sine squared of alpha. Well, 1 minus sine squared of alpha is equal to cosine squared of alpha. Okay? And so that one was pretty easy there. Now, I actually didn't even see it. I'm going to show you the first time I worked through it. First time I worked through it, I automatically jumped and I saw, oh, sine squared. There's GCF. Okay, I didn't even look at multiplying the reciprocals. And so the second way that you could have done it, okay, is I factored out GCF. Okay, cosecant squared of alpha minus 1 using one of our identities. Let me pull up the identity sheet, the reference sheet. The cosecant squared of alpha minus 1, we move that 1 is equal to cotangent. Right? So this right here, we could use tangent. Okay. Remember, once again, we're trying to get it equal to cosine. So this is one of the reciprocals. So I'm going to use the quotient identity to say cosine squared of alpha over sine squared of alpha. We got the sine squared. So these are going to cancel. When we multiply, you have a common factor in the numerator and the denominator, they're going to cancel out. So you're with cosine squared, all right? So either way is perfectly acceptable, all right? As long as you use acceptable identities to get from one step to the next, it's perfectly fine, all right? So like right here, we multiplied, all right, using our reciprocals, and then we used Pythagorean, okay? We factored, we used Pythagorean, and we simplified, okay? Both are acceptable ways as long as you are verifying that both sides are the same. Okay, we got one more we're going to do here on the notes. So this one we got tangent of x times secant of x over tangent of x minus tan of x over secant of x equals cosine of x. All right, so first thing I want to, we've got a lot here that we got to simplify down, right? And so when you're doing these, you want to be thinking about those different identities, right? What gets things down more? Now, the biggest identities, right, when you're trying to take a lot to bring it down to a little, is those Pythagorean identities, right? And those are going to be our friends here is because, look, sine squared of theta plus cosine squared of theta equals 1. Tangent squared of plus 1 equals secant squared. Or if we rearrange that, secant squared minus tangent squared is equal to 1, okay? And so in this particular problem, when we're looking at what we have in the parentheses, we have a lot of the tangents and secants. So when we combine these, think about what the common denominator is going to be, okay? So we're going to work inside the parentheses here. And my denominator is going to be tangent of x, secant of x. Okay, so here we have to multiply it by secant. So we multiply secant by secant, we get secant squared of x. Here we have to multiply secant by tangent, so we get tangent squared. Okay, I'm just going to bring down tangent of x so we don't lose track of that. All right, we're going to go ahead and combine those. Okay, we just talked about secant of x minus tangent squared of x right here. All right, that's that identity. We subtract the tangent squared, and that's equal to 1. So this whole thing right here is 1 over tangent of x, secant of x, times tangent of x. Okay, we actually multiply that. Okay, the secants are going to cancel, left with 1 over secant of x, which equals cosine of x, which, remember, that's what we're looking for. All right, so we're able to verify it. So, all right, let's do a little quick recap, and then that's going to be it for the notes for today. So what did we do first? Okay, we found a common denominator. Okay, so then we subtracted. We used Pythagorean identity. Okay, secant squared of x minus tangent squared of x is equal to 1. That's Pythagorean. Okay, we multiplied and we simplified. Okay, multiplied, simplified, and the very last one, 1 over secant is one of our reciprocals. Okay, and we got cosine of x is equal to cosine of x. All right, that's it.